Our next presenter, Pete Schultz, comes from Bell Helicopter. He'd been working in the industry for tens of years. I'll just say it that way. Been around for a while, and he's been handling not only some of the things that are going on with the government, but also in the commercial side. And I asked him to kind of elaborate a little bit on, we just had our government guys come in and tell us what we think that we're going to be doing or are doing, and the question then was, give us some examples of commercial that make sense for us to emulate as a part of that. So Pete, over to you, brother.
Yeah, thank you, Dr. Lewis. Hey everybody, sorry I wasn't able to join in person this morning. Today I've got a meeting here in Texas I absolutely have to be at tomorrow morning, and our weather is a bit iffy. It's sleeting outside, 24 degrees here. It was 80 on Monday, so that's your Texas weather for you. So actually, I would like to show a couple videos, short videos, and then I've got this chart and another chart. And as we watch these videos, one's about 525 and one is about our 505 product. I want you guys to be thinking, guys and gals, be thinking about, Matt said it well, how do we leverage these, how do we, do work differently, leverage these new capabilities? And really the focus is on, how do we leverage digitally designed aircraft, and how do we leverage digitally enabled aircraft? So I think I've got about 3 or 4 minutes of videos here I want to watch with you guys, and then I've got some bullet points to kind of help talk through what we're going to see there, and hopefully spur some discussion. So we could go ahead and roll the video.
Sure. Would you like the 525 video first?
Yes, please. And then right after it, the 505 would be great. Thanks.
Great. Okay. And if you'd like to narrate, you'll have to unmute your mic after the video starts playing. I'll go ahead and start playing this one.
All right. Thank you.
The Bell 525 is the world's first fly-by-wire civil service rotorcraft. But it's also setting new standards for excellence in performance and operational efficiency. Engineered to perform exceptionally in the harshest environments, the 525 delivers an unmatched quiet cabin experience, low vibration for passenger comfort, and capacity for up to 16 people. Along with triplex flight controls and hydraulic systems, the 525 is equipped with the most advanced integrated vehicle health management system, or Aviation, in the air today. Designed to detect a potential problem and inform maintenance action before it affects flight operations. The aircraft's Aviation instantly diagnoses fault code criticality and sends the code via satellite uplink to a mission link base station, where Bell's interactive electronic technical manual, or ITEM, takes it from there. Programmed to reflect the exact configuration of each aircraft, the ITEM translates the code down to a single fault isolation procedure, giving technicians specific instructions in real time, substantially reducing troubleshooting time. For electrical or data faults, interactive wiring diagrams provide a logical overview of power and data paths. This is directly tied to a 3D digital twin of the 525, showing every harness and connector and each part's precise location, as well as the accessibility areas. The 525's ITEM delivers clear procedures using simplified technical English and S1000D standards. The aircraft's ultra-intelligent data pathway management system and integrated ITEM makes scheduling repairs and orders seamless, so parts can be positioned on the ground even before the aircraft arrives. This enables technicians to be fully prepped and ready to repair the aircraft, and gives the 525 a quick, efficient, and safe return to service. With a maintenance schedule capable of needing 35% less man-hours versus comparable aircraft, and with one of the lowest costs per flight hour in its class, Bell is proving that when it comes to performance, comfort, safety, and cost of ownership, the 525 is in a class of its own.
Okay, I'll go ahead and share the next video.
Thank you.
we started building a platform for courseware development that would allow the instructors to teach in a way that's familiar to them, but hopefully enhance student engagement and pull people in a little bit more.
You can sit down in a classroom and still see the parts as if you're looking at it on the aircraft. It has the same materials, the same textures, and the look. We're showing you what to take off in what order and why to take it off in that order. So when I walk out from the classroom out to the aircraft, I already know that the yellow cap on the back of the tail rotor gearbox is where I'm servicing for the oil.
Nick and Zeke and Clyde first showed the Unity software to us. It was during just a regular meeting, and the first thought I had was, wow, there's so much we can do with this, so much more information we can deliver to the customer. And I find that they're more engaged with me as the instructor. They're focusing up where I'm teaching, they're looking at the board, they're looking at the component, they're more focused and they're more engaged.
Everything that you want to see in a real environment or an augmented environment, something that looks real in front of your face, something that you're just like, that's crazy that I'm actually getting to see something that looks this amazing and I'm going to learn from it. I'm not here just to ooh and ah over it, it's actually going to teach me.
I feel like Unity puts us above anything that they've ever seen before. Going from a PowerPoint, to this 3D interactive, high speed, new technology is just, it blows my mind every day what these guys have done with it.
Okay, we could go ahead and throw the slide up there. Great, awesome. Okay, so my intent, wasn't to market the 525 there, but really kind of highlight, how we can take advantage of, both digitally designed and what I'm calling digitally enabled aircraft. So 525, 505, very different aircraft, but both were 100% model-based definition. Both delivered MBD in lieu of drawings. I remember Dr. Lewis mentioning early on, the drafting boards, the erasure shields, and the cultural element of this has been very difficult. So, fortunately for us, 525 and 505 developments were kind of overlapping and on top of each other. So we had a lot of lessons learned there. But really, this is a must do. We really need to transition to model-based definition, and I'm talking here about physical product structure, leveraging the engineering CAD models downstream in particular. Digital mock-up collaboration, critically important, especially if you have teammates. We had teammates, so tier 1 suppliers, contractors on 525, and really important that you have that real-time collaboration, you have them in your system with you, versus trying to connect disparate systems. And when you do that, you also have IP considerations that come into play. So there's filtering that we've done to limit what a supplier can see in our space to make sure that they're getting the appropriate context, the appropriate ICDs, so they can go do their work effectively. Yet we want to keep them on a need-to-know basis and kind of limit them to what they can see. Model-based definition, consumption downstream. Again, a lot of lessons learned there, particularly with supply chain. In-house in our COEs and our assembly centers, it's been much easier for us because we're kind of in control of our own destiny there. We have our the appropriate tool sets and training. But extending that, consuming that by our supply chain, we have had some issues there, and have really been able to mitigate most of those as we deal with with the Army for FVO programs. Expect that we have some opportunities there as well as some challenges. We talked a lot about single source versus authoritative sources of data. Really, that ASOT is critical. I don't know that the single source is really achievable. We have multiple data systems in-house at Bell. We want to be able to aggregate that data in one place where it's useful. We want to aggregate, our operators' data, whether that be the government, whether that be a commercial operator. We want to aggregate our partners, our contractors that also have a stake in a particular platform development. We want to pull that data together in one place where it's accessible. And then, below that, when you start talking about data formats, particularly with 3D CAD data, it's very problematic when you're dealing with native CAD formats versus neutral versus viewable. 3D PDF and now in 31 Mill Standard 31000B, we've introduced what we call a 3D intelligent PDF. But that's really been a game changer for us. That's one of the areas that has helped us with supply chain consumption of model-based definition. But really wrangling all that has been a challenge, and I think will still be a challenge going forward. And that's really some opportunities there for us to make sure that native CAD formats, comply with STEP standards, so that when we convert those models, we're getting the same data that but in that different neutral consumable format. 3D publishing applications, so tremendous value in leveraging engineering source CAD data. Again, this is an authoritative source of the truth, critically important with keeping that information, those models, that data synced back to the source. But we found that, once you pull out of the source system, out of CATIA, and put that into a publishing tool, and you begin to author that data and filter that data, it's problematic in keeping that synced up to the source and preserving that authored content at the same time. EBOM, MBOM, SBOM, I got question mark bomb. Keeping all of those synced up and being able to, filter out different views of the engineering bill of material, whether that's the manufacturing BOM or the service bill of material that we use to maintain, sustain the aircraft. That's been a challenge for us, and hopefully we'll see some improvements there. The question mark BOM, this is ad hoc bombs. If I want to pull certain information to convey a maintenance procedure, I may want an avionics box, I may want the wires and other things that connect to it, maybe some structural context around it. I need to be able to pull that out and push that downstream into a usable format, make it lightweight, so I can view that on a Surface, Pro tablet versus an engineering workstation. And then the last bullet there, I want to be able to pull that into a virtual reality session, whether I'm validating a 3D design before I go commit those models to hardware, or if I'm using VR to do a training scenario, train a maintainer before he goes and actually lays hands on the physical work product. Same for AR, MR applications. I know Army's made a huge investment in HoloLens too, so we're looking at where we can leverage HoloLens for our assembly, for maintaining the aircraft, training, being able to do a pre-flight check and showing a maintainer exactly where the components are in the aircraft that he needs to go access. There's, HoloLens is not for everything. You have some situational awareness, some peripheral blockage that may be a safety concern. So we're really looking at where is it best to apply AR, MR, or VR. Let's go to the next slide. So again, I mentioned that 525 and 505 are very different aircraft. 525 is going to be, excuse me, the first commercial triplex fly-by-wire aircraft. It has a digital backbone, and then comparing that to the 505, which is an entry-level turbine aircraft, based on the 206 drivetrain and rotor system, very different aircraft. The 525, and very similar to our future DoD vertical lift platforms, has an integrated vehicle health management system, connecting that to ground-based software. That ground-based software design is very critical, and we need to make sure that We have appropriate user interfaces, whether we're pushing information to an analyst or we're pushing information to a maintainer, plane side or aircraft side. The latter being, red, yellow, green indications. Tell me what's wrong. Tell me how to go fix it. Cybersecurity requirements, those are continuing to evolve, particularly in the DoD space. You saw the lightning bolts coming off the rotor system and off the nose of the aircraft in that video. We need to be very careful how we leverage RF technologies, things of that nature, and making sure that we're baking in cybersecurity requirements along the way. Integrated 3D IEDM, fault to fix, and not only fault to fix, but once we determine what the problem is, being able to go to that shopping cart and order that part. This is what a digitally enabled aircraft provides us, that kind of opportunity to where we can combine HUMS information or IVHM information coming off the aircraft and integrate that with the 3D CAD formats and all the metadata that's associated with those 3D part models to really give the maintainer a very clear view of what he's working on and where it's at, and again, leveraging that model-based definition. Integration of OEM and operator fleet management data. This is very, very important. We have some emerging requirements around this. With our commercial operators, typically we're in sync and they're providing us maintenance records during the warranty period. A lot of times, they kind of go radio silence after that warranty period. When we're looking at, future DoD products, DoD will keep an airframe like they kept Black Hawk for 40, 50 years. We really need to make the investment there. We really need to make sure that we're getting timeliness of data and we're really connecting, both the OEM and operators' business systems to support fleet management, support fleet readiness. Tail number configuration management, so digital backbone, member reporting systems. This is a huge opportunity for us, and this has really been a problem for us in the past, being able to manage tail number configurations. We'll have a serialized blade, and based on the information we're getting, we're seeing that blade on 2 different aircraft at the same time. Or we'll have, here the 525 graphic, we've got 5 blades. We'll have 6 blades on that aircraft. So again, leveraging the information that we're able to capture on that aircraft is critically important. And coupled with that, how we record maintenance, and maintenance records management. Tremendous opportunity there, looking at leveraging RFID to basically scan off, scan on components, so we're not fat fingering serial numbers, making errors and data entries based on what's being done, and again, leveraging that digital information that's available on the aircraft. Looking at how can we auto populate some of the maintenance forms that the maintainer is entering data into, so we can really bake in quality of data right as up front as it's being collected. And so not only data quality but consistency, completeness, kind of breaking down the silos, doing some checks, B&B processes, etc. To make sure that the information we're using to make decisions is timely and correct. And that feeds into the last bullet there, digital twins. And really the kind of utopia there with digital twin is being able to get to remaining useful life calculations for critical components. And it's one thing to kind of determine when a part's going to reach its life or need to be replaced or overhauled based on how an aircraft's being flown, but it's a completely other thing to say, hey, engineering said this part's good for 200 hours. I'm based on the way this air vehicle is being flown, I'm showing that it could be extended another 200 hours. So to be able to trust that data, you've got to have a lot of rigor around your modeling and simulation capabilities, your VVA processes to really, make that information believable and actionable And so that's all I prepared today. I'm hoping that this will help, again, stimulate some discussion. And I know I didn't capture everything in those 2 slides. There's additional information there that we should be looking at. So looking for input on that, and happy to answer any questions at this point. Yes.
Okay. Yeah, I was specifically interested about the airwings process and on the whole process about how you interface with the FAA, or better, how the FAA interfaces with your truth data. So my question is, how does that whole thing work? I mean, you're a DAR. Do you keep all the data and the FAA interrogates your database, or is it kept somewhere else? Over.
So I believe the question from Dr. Lewis was, how do we engage with the FAA? How do they access our data? The FAA does have access to, we're an OVIA PLM V6. They are able to access our data through our PLM system. We package that information up and send that formally, just like we would send a CEDAR formally to government. But I'm not sure exactly what the question was as far as one specific comment relative to what I was covering a moment ago, a model-based definition. So our type design data is in a neutral format. So we have what's called LOTAR, long-term archival retrieval process, where as soon as we modify, release, revise a part model, we create a step AP242 version of that. So that provides a neutral data format as type designed to the FAA. That also protects us and protects our type data against future CAD upgrades and changes to our data format. Dr. Lewis, did I answer your question?
Yeah, is that a consistent format, that long-term archival retrieval? Is that consistent across companies, or is that specific to Bell?
I think I'm not sure if that's consistent across companies. That's our approach.
Okay.
And we provide both native and neutral formats, but our type design is in step format, a neutral format.
Mike, did you want to answer?
Similar processes.
Okay, Mike Ambrose is here, and he says they have a similar process. I'm not sure if it's driven by. Do we have anybody from the FAA online?
The Air Force specifies 242 generally is their neutral format.
What was the format again?
Step AP242.
AP242.
Step 10303 AP242 is the neutral format that I believe is the current one called out. Excuse me, in the Air Force model-based product data specification. So we are on the Army side running behind them, but in general, that is the most pervasive and well-adopted neutral standard.
Okay.
We have Robert Stoiber from the FAA on.
Yeah, good morning. This is Bob Stever. I'm with the FAA, the Military Cert Office in Wichita. And I do have a question, and the gentleman asked if anybody was on the FAA. I thought we had several, but maybe I'm the only one today. You've got data, you've got a model that basically describes your type design. I'm curious, how do you go about doing the showing of compliance to the various regulations with this model? I mean, it's one thing to have the model describing the type design, but you've still got to do a showing of compliance. And as you know, the traditional approach is to write a pile of reports that get submitted to the FAA. And now that showing may be in a different scheme or a different form. Can you tell us a little bit about that? Over.
Yeah, the delivery of the model is just one element of our certification. So we still provide a pile of documents. You know, whether it's stress analysis, performance, test plans, test results, SIL data. You know, systems integration labs are a very, very important key element to helping reduce your flight test program, compress it. We are doing more and more tests for credit in our systems integration lab, and that really requires a lot of rigor around configuration management and your verification, validation, accreditation processes. You know, and then there's a kind of a digital twin element. It's both hardware and software in the loop for our systems integrations labs. But to answer your questions, the model, the engineering models are just one deliverable of many to the FAA for our certification.
Okay, thank you, sir.
So I just want to clarify with that those flat files are in there. Those are flat files largely for your type design, which are CAD dominated files, right? They're not every flight control system design. They are not every requirements document in a model format. All those other things are delivered in a text-based environment to the FAA, correct?
Yes, sir. And so you're looking at 525, 505. Those product developments began back in the 2010 timeframe. We're using RBE, requirements-based engineering, through Innovia V6. So MBSE, that is a new requirement for us, driven by FLRAA and FAR programs. So you know, that there's rigor, systems engineering rigor, but it's very different than the tools that we're working with today, you know, like Cameo and Dia Magic now.
So we still have the challenge of trying to figure out how to get these broader based, model based integrated tools into some format that collectively can be archived and used for sparing well into the future.
Yes.
Thank you.
Yeah, yes, and that's really that's the key, is being able to bring all that data together in one place and in usable formats. And you may not, the bringing the data together in one place may be transparent. You may be actually providing access to an OEM source system, and other data you may be aggregating in another environment, but that should be kind of transparent to the user. But in the end, you want to provide the right data to the right, you know, folks based on their role.
So would you say that during the development, potential for a single source of truth at an OEM as they're developing the aircraft, but as you migrate out toward life cycle management, you migrate toward an authoritative source of truth that points to the documents that are relative and the models that are relevant in order to do life cycle management over time? Is that a fair thought?
I think, well, life cycle management's going to be on both ends, both the source data, and then you've got to sync up, you know, your authoritative source data. I think that the ASOT is again making data available to the enterprise, to all stakeholders that might not either have the appropriate tools or skill sets to access those data otherwise. So if you look at CAD data, it's much more consumable when you get it out of the source CAD system into a lighter weight consumable format. And from there, you could start to integrate other business systems information that's not in CAD and push more metadata towards those part models.
Thanks.
Other questions?
I have a question, more of a thought. So for subsequent topics, you know, since low tower was, you know, one of the use cases in AP 243, you know, maybe we want to do a dive in that and have FAA representation and, you know, OEM representation, you know, in that kind of a working meeting to see if there, you know, so we can avoid maybe reinventing some of the wheel there and improve scalability.
Okay, great. Yeah. And Jim, did we figure out how we're going to get input from the folks here for the survey?
Yeah, eventually. Yeah.
Okay.
We'll get an email afterwards.
All right. Yeah. The point you made was you'll get an email after this meeting and you'll have an opportunity to input suggestions just like that. So if anybody else has a suggestion of, where we can go, that'd be great if you could reply to that
Okay,
mail.
super. I didn't know about that already.
Yeah.
For those that are logged in virtually, it'll come when at the end of the webinar.
Hey, Pete, another question and kind of changing gears. When you, have you exercised the sustainment piece of that? In other words, you got a P-bomb, now you're going out to get parts. Have you exercised that digital thread that goes down to the individual component vendors for your aircraft and, obviously an airworthiness department?
We're doing that, but it's not at all optimized. We, these like 525, it's yet to be fielded. And we're kind of in development on some of the future DoD platforms. So, I would say we put a lot of effort into tracking a part from cradle to grave, and kind of really establishing that digital thread. And again, it goes back to, capabilities. And if you look at a product like V-22, was designed 30-ish years ago. We don't have the amount of data, and we don't have the integration of maintenance systems and contractor and operator that we will have in the future. So yeah, we're not there yet, Dr. Lewis, as far as leveraging these capabilities like we showed with 525. We demonstrate those, but we haven't really fielded that product and haven't made that tie-in with our customers.
Hey Pete, this is Dave Guzinski. Do you feel like you want to address future where you're going with unified product structure, which provides that unified BOM from E-BOM to M-BOM to service BOM, the SID?
Well, yeah, you're a great straight man, Dave. Yeah, we're working with Dave and Dassault team to move from, we're currently in a Novia V6 to the 3DX platform, and they're using a common data model, so that's a big enabler for us to kind of weave the thread and connect. It's in the end, it's kind of the same number of parts, but they're ordered, constructed differently between your service bill of material, manufacturing bill of material, and engineering bill of material. And I would, one other comment I would add is that, I had that question mark BOM. I see us potentially, we'll see where we go with 3DX, but, potentially we're developing in-house tools to kind of help filter down to what I would call an ad hoc BOM that might support a maintenance removal procedure.
Hey, Pete, I'm going to ask you a question. It may not be fair, and if it's not, you can not answer this one. But I've been a big advocate of taking a look at as you develop a product to be more than just a flyaway airplane, but to be a continued maintenance aircraft throughout its lifetime. Okay, but when you do that, I mean, you talk about warranties, and I know there's a warranty period. When you do that, how do you wind up pricing into that product the continued airworthiness maintenance of that aircraft as you get out of a warranty program? Is there a fixed way of doing that?
Are you alluding to like PBL type contracts? Or?
Well, I'm not so much PBL. What I'm saying is it could be like a PBL, but it would probably be like a pseudo warranty / priced availability kind of thing.
Yeah, I don't know that I'm intelligent enough to comment on that one. I would definitely misspeak on that one. I'm sorry, Dr. Lewis.
Well, the only reason I asked that question is because I think as we look forward, and especially if we're starting to do remaining useful life, and the only person that's going to have the data to be able to do that is the OEM. And as we get ready to do that, how do you leverage that if you don't have a continued relationship with the OEM?
Oh, absolutely. And that's, that's what I mentioned earlier about integration of OEM and operator information systems. So, in the timeliness and accuracy of that data. So I would say it goes both ways. We need the operator's data, and the operator needs the OEM's data. The operator, they have the kind of option to provide us their HAS data or not, to provide us their maintenance records or not. And, all those pieces come together along with the OEM's data to give that, that big picture and eventually help inform digital twins and help, move towards, you're the father of the maintenance-free operating period. To really achieve that goal, we've got to both operator and OEM share data, have openness of data and timeliness of that data.
Okay, let's say you fly outside the warranty period, and then I decide as an operator not to renew my warranty. Does the limitations of the aircraft change at that point? Because you had monitoring availability of the data when it was under warranty, but then when it goes out of warranty and they're not providing that data, do you have to go back to a different profile since you're not monitoring the activities of the aircraft?
I think there's just an opportunity lost there. I don't know that, the operator has that data. A lot of times the operator will stand up their own analytics capability, their own fleet management capability. So I don't know that. I think it's just a matter of losing some opportunity there.
Yeah, but they won't be able to go back and review TBOs at that point. They don't have that capability.
I wouldn't think so.
Any other questions for Pete before we bail? No, Pete, I appreciate you coming on and thank you much for your participation.
My pleasure. Thanks for listening. Thanks for the discussion.